Now I want to explain how we come from the condition in the proof to the condition of the theorem. So in the proof we got that R1 must be bigger than the entropy of X plus R1 prime. Furthermore, it holds that R1 prime is of course smaller than R1 prime plus R2 prime. This is from our proof, we will know that this is smaller than the mutual information between X and Y. But this we can write as the entropy of X minus the entropy of X under the condition Y. So if we just put this in, we got that R1 is bigger than H of X under the condition Y. That's the first point in the theorem. Now let's clear the page. The same works for R2. It works in the same way, of course. Perhaps I just write it down. So we have that R2 is bigger than H of Y plus R2 prime. And we know that R2 prime, of course, is smaller than R1 prime plus R2 prime, and this is by our condition smaller than the mutual information between X and Y. This we can write as a mutual information as a entropy of Y minus the entropy of Y conditional on X. And if we put this in, we got that R2 is bigger than H of Y conditional on X. Yes, that's the second part of the theorem. And for the first part, we use both. We use the condition that R1 is bigger than H of X minus R1 prime, and R2 is bigger than H of Y minus R2 prime. Putting this both things together, we have that R1 plus R2 is bigger than H of X plus H of Y minus R1 prime minus R2 prime. But we know again that R1 prime plus R2 prime is smaller than the mutual information between X and Y. And this, of course, we can write also as as entropy of Y plus the entropy of X minus the entropy of X, Y. So if we put this in, we have R1 plus R2 is bigger, and now this cancelled out. RH, the entropy of X minus entropy of X, this minus this becomes positive, is Hx and Y. And that's the third condition of our theory.